Hi, this is Peter with CalcBook, and today we're going to be doing a short video on gusset plate buckling. So a quick recap here, gusset plates can fail in buckling when loaded in compression. And there's two critical components when we're looking at buckling of a gusset plate. So the first is the Whitmore section. So in a gusset plate, right, you can have a pretty large width at the end of your brace, welded connection or bolted connection. And so we don't take that full width when we're looking at compression. So we have this Whitmore section that we use, which is 30 degrees away from either the bolted line of action or the welds. And the second component is the unbraced length. So this is going to be the distance from the end of the brace to the fixed edge, right? So that's typically going to be your beam or column interface. And a couple things to note about this, right? When you have a steeper angle on the brace, like in that second image there in the lower right corner, your Whitmore section can extend beyond the interface of the gusset and the beam. So you are permitted to take the Whitmore section into that area if it's a fixed connection there, so a welded or bolted connection. You can go across that interface, but we can take off the unbraced length there and subtract that. So we can take basically the average of L1, L2, and L3 as our unbraced length, and that's what we do in CalcBook. And there's a really good reference document here, the Modern Steel July 2011 issue, page 52 to 56, which there's also a sort of an accompanying AISC video on YouTube, which I'll put a link in the description, that talks about these things here for buckling of a gusset plate in more detail. So please check those out. So let's take a quick look at our problem statement here. We've abbreviated a lot of the inputs required for a vertical brace connection because we're only focusing on the plate buckling, but we've got an angle of 60 degrees from the vertical. Our half depth of column is 6 inches, half depth of beam is 6 inches, and we have a 3/8 thick gusset plate of a 8036 steel. We've got a 4-inch wide brace that is welded to the gusset plate, and we've just got a 25 kips compression load on the end of the brace there. So we're just going to take a quick look at the buckling of the gusset plate and see what that looks like. So let's go ahead and open up CalcBook and we'll get started on the design. All right, we've got CalcBook open now. We've already got all of our parameters set up here. We've got our demand of our 25 kips. We've got all of our gusset plate information already entered. We can toggle our forces on and off here to see what the forces are at each interface. But the one thing we're interested in here is going to be the gusset plate buckling. So let's go ahead and scroll down here to our capacity calculation. We'll go into brace gusset, and then we'll look at our gusset plate buckling. So the first thing we're going to look at is our geometric values we need to figure out. So our Whitmore width, right, we talked about is going to be calculated based on that 30-degree angle from the weld. And just one thing to note here about the Whitmore width, if the Whitmore width extended over the unbraced edge of the gusset plate, we would not include that. But since it extends over the welded interface between the gusset and the beam, we can include that extra distance there. So continuing on here, then we calculate the gross area of our section, so the width that we just calculated times the thickness of the gusset plate. Then we calculate our unbraced length, right? So because that bottom corner of the Whitmore width does extend over the beam there, we can use this as a subtraction, right? And then we average everything out, and we get an unbraced length of approximately 4 inches, 3.92. Then we calculate the radius of gyration, which is our thickness over the square root of 12. And then we calculate our effective slenderness ratio, which is going to be K times L, right, KL over R. And our K of 0.5, there's some documentation in some various AISC articles about this factor. And you can adjust that here in the brace to gusset input section. But we'll post some information in the description below about this. And then we move on to our buckling capacity. This is just our standard Chapter E calculation. We go through that. We get our buckling stress, our critical stress here of 35 KSI, then we multiply that by the gross area that we calculated before, and we get a total buckling strength of 160 kips, 158.11. So plenty of capacity for this design, but that is just a short overview about buckling in gusset plates. We hope you enjoyed the video. Please let us know if you have any suggestions or suggestions for other videos in the comments below, and we'll see you next time.